Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we completed the mechanical properties of solids chapter, right? So today we are going to start one more interesting chapter, and most of the students feel difficulty in this chapter. So same how we dealt in the rotational motion step by step, so here also we'll deal the concept step by step. Okay, first we'll understand the basics, so then we'll go for the advanced problems as well. Okay, chalo. So mechanical properties of fluids, lecture number 1 today. So where we are going to discuss, so what's a pressure in fluids, the density of the fluids, and what is the relative density, and we'll also solve the YouTube problems. So this must be 3, right? Yeah, so this is the 3. So we'll also solve the YouTube problems. YouTube problems means not that YouTube on which you are watching the lecture. So it's a U type tube. Okay, chal. So let's go for the concept. So first, the liquids and gases can flow and are therefore are called fluids. See, fluids means not only the liquids, so the substance which can flow is called a fluid. So the gases can flow from one place to another place, and also the liquids can flow. So these two combinedly they are called the fluids. Okay, so the basic thing. And then an ideal fluid is one which is so incompressible and non-viscous. So practically we do not get any ideal fluid. Okay, so we assume, so if in fluid statics we are going to deal it in 2 parts. So one is fluid statics, the other one is a fluid dynamics. So throughout our lecture we assume, like today's lecture and tomorrow's lecture, fluid statics. So we'll assume, so the fluid which we are going to consider, it's the ideal fluid. So what are the ideal fluids, sir? So which are incompressible. So incompressible means whose volume is fixed. So whose volume is fixed. Whose volume is fixed. So if the volume is not going to change, so then the density is going to be constant. If the volume is not going to be same, so then the density is going to be constant. So in the last session, while discussing about the bulk modulus of elasticity, if any object, if it is placed under the fluid, so its volume gets decreases, mass remains constant, so that its density increases. What's the new density that we studied? The rho dash is equals to rho into 1 plus delta P by B. Yes or no? So unlike there, here in fluid mechanics, in the mechanical properties of fluids, we consider so the ideal fluid, so which is incompressible, which means volume is fixed and the density is going to be constant. And one more important property for the ideal fluid is it's non-viscous. So non-viscous means in liquids, so if a fluid is flowing over the another fluid, so then we can say there is a viscous force. Okay, so it's non-viscous means no tangential force or the no tangential stress. So the NCRT line, so that is no tangential stress. So see, if one liquid is flowing the another, so which means, so there is a tangential flow, tangential force is there, right? So that tangential force, if it is absent, so then it is said to be the ideal fluid. So ideal fluid has 2 important properties. One is incompressible, the other one is a non-viscous. So no tangential stress or no tangential force, we can say. No tangential force. Done, guys? Clear? Chalo, good. So next, let's move further. So now let's come to the concept that is pressure. So what is pressure? So pressure is nothing but the force upon which forces are the perpendicular force. So the perpendicular force upon area. So this pressure is a scalar quantity. So the pressure is a scalar quantity whose formula is given by, so the perpendicular force upon area. Okay, so the pressure acts at a point in all directions. Remember that point. So the pressure pressure acts at a point in all directions. In all directions. Clear? Chala. Good. So next, if you want to find what is the force, so then that force will be equals to, we can write the pressure into area. So the pressure into area. Clear? So this is the area. So if some force, perpendicular force is acting on it, so the pressure at that point is given as force upon area. So the perpendicular force upon area. So what are the units of the pressure? So we can write, so Newton, force Newton, area meter square, or which is also called the Pascal. So which is also called the Pascal. So now for you the homework is write the dimensional formula. So mention what's the dimensional formula for the pressure. So write what is the dimensional formula of pressure. So take this as a homework, guys. Done? Clear? Sure. So next, let's move further. So now what are the units of pressure and what are the units of volume? See, pressure is generally measured in, so the atmospheric pressure in ATM. So 1 ATM is equals to 1.01 into 10 to the power 5, so Newton per meter square. Okay, so or approximately this can be written as, so 1 into 10 to the power 5 or simply 10 to the power 5 Newton per meter square. And so 1 Newton per meter square is nothing but the Pascal. So 1 Newton per meter square is also called the Pascal. Okay, so here, so which we can also write it as 10 to the power 5 Pascal. 10 to the power 5 Pascal. So this is a pressure, or which we can also write it equals to, so 1 bar. So 1 bar, or which is also equals to 760 mm of Hg. 760 mm of Hg. So these are all the units of pressure. Done? Chalo. So and then what are the units of the volume? So volume units are, so either meter cube or the centimeter cube. Either meter cube or the centimeter cube. So this we can also call it as cc, centimeter cube. So this is meter cube. Okay, done? Clear, guys? Chalo. So you know how to convert the meter to centimeter and centimeter to meter. So this is the basic information related to the pressure and the volume. So let's take one simple question. So what's the question says here? Try to do this question on your own, guys. So what's the question says? The two thigh bones each of cross-sectional area 15 centimeters square support the upper part of a person of mass 70 kg. Fine. So then the pressure sustained by these thigh bones is, so the pressure sustained by these thigh bones will be, see here. So there are two thigh bones, so and the upper part of the body is managed by the support of these thigh bones. Okay, so chalo. So then what is the pressure sustained by these thigh bones? So what's the pressure formula? The pressure is nothing but perpendicular force upon area. The perpendicular force upon area, right? So then, so what is the force here? So how much force? The force is nothing but the weight. The force is nothing but weight of the first person here. So let the weight be mg. So the in place of force I am writing mg by the cross sectional area. So what is mass? 70 into g 10 by, so this is 15 into 10 to the power minus 4. Yes or no? So I am converting it to meters, right? Chalo, done. So then, so we have got two thigh bones. So each one cross sectional area 15, right? So 2 into 15 I am writing. So then I'll get here, so 70 into, so if it goes up 10 to the power 4, so which will be 10 to the power 5. 10 into 10 to the power 4 is 10 to the power 5. So this is 30. So 0 0 cancel, 3 ones are, so 2 and then 1 0 3 3. So like that. So this will be 2.33 into 10 to the power 5. So the Newton meter square, Newton per meter square, or So the correct option is here. So we have option 4. Clear? Understood, guys? Good. Next. Simple question. So now let's go for the pressure in the fluids. See, so why the pressure occurs in the fluid first of all? So the fluid, molecules of the fluid, they collide with the walls of the container. So it creates a pressure. Okay, so why the pressure arises in the fluid when it is poured in a container? So because the molecules of the fluid, so they collide with the surface, they collide with the wall of the container, so that they there creates a pressure. Okay, so that's what I wrote. When an object is submerged in a fluid at rest, so the fluid exerts a force on its surface. The fluid exerts a force on its surface. Yes, so this force is always normal to the object's surface. This force is always normal to the object surface. So the force is equals to how much force they exert. So the force is equals to pressure into area. So the force is equals to pressure into area, or we can also write it as, so the pressure is equals to force upon area. So whenever an object is placed inside the liquid, so it will experience a pressure. Okay, that's what I wrote. When an object is submerged in a fluid at rest, so the fluid exerts a force on its surface. The force is always normal to the object surface. So here you can see here. So let's suppose an object is placed. So from all the directions, this object is experiencing the pressure. Right? Done? Sure. Basic things. So and then what is the density of the fluids? So density is nothing but, what's the formula? Basic formula. So we have mass of the substance by the volume. The mass upon volume will give the density. Yes. So what is the mass? If you take the SI units, so the SI units will be kg per meter cube, or we can also write CGS units gram per cc, centimeter cube. So in our upcoming classes, we should remember some formulas to solve the questions. Like for upcoming classes, we should remember some values of the density. So especially the water density you should remember, which is 1 into 10 to the power 3. So the density of water, so which is 10 to the power 3 kg per meter cube. So you should remember this value. And then so the mercury, so the density of the mercury, so which is 13.6 kg per meter cube. So if you need it in gram per centimeter cube, so just divide it by 1000. If you need it in gram per centimeter cube, just divide it by 1000. So which is nothing but 10 to the power 3 by 1000, which is 1 gram per cc. Okay, or so for mercury, so it is 13.6 gram per cc. Okay, and one more thing that you have to remember. So for the alcohol, here ethyl alcohol is mentioned, which is 0.8 into 10 to the power 3. Yes, 0.8 into 10 to the power 3. So kg per meter cube, or which we can also write it as 0.8 gram per cc. Then so these three values, and along with this, so you also remember for the air, which is 1.29 kg per meter cube. So 1.29 kg per meter cube. Air is 1.29 kg per meter cube. Clear? So these are the basic values everyone should remember, guys. Done? Clear? Chal. So let's move further. So now let's go for what is the relative density or specific gravity. So the relative density RD, it is nothing but the density of a substance by density of water at 4 degrees centigrade, by density of water at 4 degrees centigrade. So density of water at 4 degrees centigrade. So this is a relative density concept. Okay. So here the units, there are no units for the relative density, because numerator is density and denominator is density. Sir, why only density of water at 4 degrees centigrade? Because the density of water is maximum at 4 degrees centigrade. That we will discuss it in the thermal properties of matter next chapter. So as of now you just take the density of water at 4 degrees centigrade, this part. Okay, so this is a relative density. Done? Clear guys, everyone? So if you take this relative density, so here gram per cc, here gram per cc, so in gram per cc if you take, so then that is said to be the specific gravity. That's it. The specific gravity is nothing but if you take the density of the substance and density of the water in gram per cc, in CGS units if you take, so that relative density will become the specific gravity. So relative density will be equals to the specific gravity, will be equals to the specific gravity. So if, so the units are gram per cc, so that means the numerator and denominator you should take the values in gram per cc. Okay, na? So then that's it. Then it's said to be the relative density is equals to the specific gravity. Done guys, basic formulas, basic information, just try to understand this, so then we'll go for the advanced concepts. Chal, so let's go further. So density of a mixture of 2 or more liquids. So if there are 2 or more liquids are combined, so how do we take the density of that mixture? Suppose 2 liquids, they have the densities ρ1 and ρ2 having the masses, so m1 m2 are mixed together. So then the density of the mixture, always remember the density is nothing but, so total mass by total volume, total mass by the total volume. So but you write these in terms of the given quantities. So here the masses are given, the total mass will be m1 plus m2, yes, but here there is no volume, right? So here there is no volume term. So can we write volume in terms of their density and mass? We know that the density is equals to mass by volume. From here, so the volume is equals to density, mass by density. The volume is equals to mass by density. So the volume is equals to mass by density. So here, so in place of volume, so V1, V2, actually it should be V1, V2. So now what I am writing is, so M1 plus M2 by, in place of V1, so let me write M1 by ρ1 plus, in place of V2, so I'll write M2 by ρ2, because the given statement is given in terms of only the densities and masses. So I am eliminating the volume term. Clear? Chal. So then case 2, if 2 liquids have densities ρ1 and ρ2 having volumes V1 and V2 are mixed, so then the density sorry, same concept. So it's going to be total mass by the total volume, the total mass by the total volume. So here what is the total mass? The mass, total mass, they did not talk about the mass here. So what I will do is, first let's write mass, and then so here volume, the total volume will be V1 plus V2. So we know that density is equals to mass upon volume. So from here, so the mass is equals to density into volume. The mass is equals to density into volume. So in place of M1, so I'll write, so ρ1 V1 plus, in place of M2, I'll write ρ2 V2 by, so V1 plus V2. So hope you already came across these concepts in chemistry, right? Chal, good. Next, so we have got one question. Let's try to solve this question, guys. First read the question and try to do this on your own. What's the question says? 2 liquids of densities 2ρ and ρ having their volumes in the ratio 3:2, so are mixed together. So there are 2 liquids, let's consider. So the first liquid A, the second liquid B. So the densities are 2ρ and ρ, and their volumes are in the ratio, if A is in the 3V, so B is in V, are mixed. So then the density of the mixture. So always the density of the mixture is nothing but total mass upon total volume. The total mass upon total volume, right? Chal. So here what is the total mass? So they are not talking anything about the mass in this, right? So we know that the density is equals to mass upon volume. From here, mass is equals to density into volume. Here mass is equals to density into volume, right? So the total mass, which is nothing but MA plus MB, let me write this way, by, so total volume VA plus VB. So let me write mass in terms of density and volume. So the MA is nothing but rho A VA plus, so MB rho B VB by, so VA plus VB. So now let's substitute the values. See here. So I have got rho A is 2 rho into, so volume of A 3V plus, so rho V, rho B is rho. So what is volume of B? So 2V by, so VA plus VB 3V plus 2V, which is 5V. So I can cancel V in the numerator and denominator. So and then what's the remaining term? So we have got 6 rho plus 2 rho, which is 8 rho by 5. Yes, so which we have got 8 rho by 5. So option 3 is the correct one, guys. Done. Understood? Clear? Good. So now, how the variation of pressure varies with respect to the depth. See, so for any object, so for any container like this, so the atmospheric pressure, which we call it as P naught. Now in this container, if you place an object at some height h, if you place an object at some height h, so then the density here will be not same as of the surface. That's for sure. The pressure increases with the depth. Okay, so that's first thing. The pressure increases with depth, right? Chalo. So now the pressure at the bottom, let it be P, which is equals to, so how much it increases? So the P naught plus, so P naught plus, so rho GH. So the P naught plus rho GH. So this is the pressure at the some height h. Pressure at some height h is equals to P is equals to, P naught is the atmospheric pressure plus rho the density of the liquid, and G acceleration due to gravity, and h is the height at which the object is placed. Clear? Sir, why? Why, sir? Why it's happening? Because, so there will be some weight which acts down. So what is that weight, guys? So that mg which acts down. So due to this weight, so the pressure increases. So why the pressure increases as we go down the liquid, inside the liquid? So because there will be some weight which acts, so that is mg, due to that the pressure increases. Done? Clear? Chalo. So if this P naught is not given in the question, we take it as 1 atm. If it is not given, so consider it as the 1 atm. Okay, so which is the atmospheric pressure. Right? Done? Chal. So next. So now let's draw the graph between P and H. What's the formula for the pressure? So P is equals to P naught plus rho GH in terms of the depth H. Right? So now let me do one thing. I am going to draw the graph of Y versus X. Here P versus H. So now let me write this in the form of P versus H means Y is equals to mx plus c graph, you know, right? So let me write it in that form. So Y is equals to m x h plus c. So if you compare it with now, Y is equals to mx plus c, Y, this is m and this is x, so this is c. So this is a straight line, this is the equation of the straight line having the slope rho g and the intercept C. So the graph looks like this. So here where the slope, the tan theta is equals to rho g, that slope tan theta is equals to rho g, and then so the intercept, this is the intercept, which is nothing but the atmospheric pressure P naught, atmospheric pressure P naught. So this is a basic graph between the pressure and the depth h, between the pressure and the depth h. Done? Clear? Chal. So now what is the gauge pressure and the absolute pressure? So try to understand this difference. See, as we go down, as we go inside the liquid, the pressure increases, right? So whatever the extra pressure that we are getting, that is called the gauge pressure. So the gauge pressure is nothing but it's a extra pressure. It's a extra pressure. So what is that extra pressure? So consider this is a container, so in which so the liquid is placed. So in which the liquid is placed. So if an object is placed inside it, if an object is placed inside it, so then the pressure increases. So how the pressure is increasing? The P is equals to P naught plus rho GH, right? Chalo. So how much pressure it is increasing, sir? It should be P naught. So now it increased to P minus P naught. This is the extra pressure. So this P minus P naught is equals to rho GH. So this is called the absolute pressure, sorry, gauge pressure. This is a extra pressure, or we can say this is the extra pressure. So this rho GH, that extra pressure, we call it as a gauge pressure, right? So P is the absolute pressure. P is the total absolute pressure minus gauge pressure, sorry, minus atmospheric pressure will give the gauge pressure. Clear? Done? Sure. So just remember this part. So we have got the questions here. Which of the following is correct? So what is gauge pressure? So the gauge pressure is nothing but, I can say, the total absolute pressure. This is the total absolute pressure. Total absolute pressure. So the total absolute pressure minus the atmospheric pressure will give the gauge pressure. So this is a gauge pressure. This is a gauge pressure. Done? So the gauge pressure is equals to, so absolute pressure minus atmospheric pressure, option C. Gauge pressure is equals to, it's a absolute pressure P minus the atmospheric pressure, which is equals to the gauge pressure. Done? So the option C is the correct one, guys. Done, everyone? Sure. So we have got one more question. Let's try to solve this question on your own. So what's the question says? At a depth of 500 meters, so in an ocean, so what is the absolute pressure? They are asking, absolute pressure means the total pressure. So given that the density of the sea is given, and then it's a kg per meter cube, guys. So okay, and then this is kg per meter square, fine. So G value. So see here, this is a ocean. Now the depth at a height of, or at a depth of 500 meters, so an object is placed here. So this height is 500 meters. So obviously the pressure increases. So what is the total absolute pressure they are asking? So the P is equals to, it's a P naught plus rho GH, right? So what's the atmospheric pressure we consider? So they did not mention it in the question. So we take it as 1 atm, okay, plus, so rho. So rho of density of the sea water we take. So this is 1.03 into 10 to the power 3 into, so what is the G value? So 10 meter per second square into, so what else is given? So this is, height is 500. So let's write this part again. So 1 atm plus, so 2 zeros you can multiply here. So 103 into, so 10 to the power 4 into 5. Yes, sir, no understanding? So 1.03 into 2 zeros of this I am multiplying with this, so that 103 into 5 into 10 to the power 3 into 10 is 10 to the power 4. Okay, so this comes out to be 1 atm plus, so 103 into 5, so 500 plus 15, 515 into 10 to the power 4. So this is not in ATM, but this is in ATM. So the answer should be in ATM. See here, what I will do is, so let me write 1 ATM plus, so this one 5.15 into 10 to the power 5, shall I write 10 to the power 5.15 into 10 to the power 5, shall I write this one? Yes. So now, so I'll get this 10 to the power 5 is nothing but 1 ATM. So 1 ATM plus, so not 5.15, see 51.5, only 1 0 we are writing, right? So 51.5. So 51.5 ATM. So this total comes out to be 62.5 ATM. This total comes out to be 62.5 ATM, approximately 62 ATM you can consider. Done? Chal, clear. So next, so we have one more question. So what's the question says? So the density of the atmosphere at the sea level is 1.29 kg per meter cube. Assume that it does not change with altitude. Okay, so it does not change with altitude. So then how high would the atmosphere end? See, interesting question. So they are not asking inside the sea. The density of the atmosphere at the sea level. Consider, let's suppose, so this is the sea. At the sea level, the pressure is the density of pressure. So the density. So the density of the atmosphere here, it is 1.29 kg per meter cube. Fine. Chalo. So assume that it does not change with the altitude. It does not change with the altitude. So then how high would the atmosphere extend? So the atmosphere extend means, so till what region, till what altitude the atmosphere exists. So let's consider the till here the atmosphere exists. Okay. So after that the atmosphere is not going to, let's suppose the atmosphere is not there beyond this line. So atmosphere is not there means the pressure is 0 there. The pressure is 0, right? So now from here to here I am writing the formula. From here to here. So the P is equals to, let the pressure here it will be, so some P naught. So that P naught is equals to the initial pressure P plus rho GH. Don't get confused. We are coming from the top to here. We are not talking about inside the sea. It's from how much distance, till what altitude the atmosphere exists from the sea level. That's what they are asking. Okay. So here the P naught is equals to the P initial pressure is 0. So rho GH, we have to calculate what is this H value. So the what is this P naught? So the atmospheric pressure, so which we take it as 1 atm. So rho is what? 1.29 into, so 1.29, and G is 10. So which comes out to be into H, right? So then if you calculate this H, so it comes out to be approximately 8 kilometers. So this H, which approximately comes out to be 8 kilometers. So this is the standard information, guys. You should remember. Above the sea level, the atmosphere exists till 8 kilometers, to a altitude of 8 kilometers. So the atmosphere exists. So after that, so it will not exist. Okay. Done. Chal. So let's move further. Done, everyone? Chal. If you want, you can do the calculation. See, this 1 atm, you can just write 10 to the power 5. So then you can calculate that. Okay, now done. So 4 vessels. So the interesting questions, see here, So before going for this, I'll tell one point here. So so I'll write it here. See, so this pressure at some height, so the pressure at some depth, it only depends on the height actually. It basically depends on the height. If the liquid is same, because the G value is same, the atmospheric pressure is same, and the rho is same. If the liquid is same, the rho is going to be same. So it depends on the height. So for example, so this container is there. So now if the same thing, if I write it in this, so the same liquid I filled it in this tube. So here height h, here also the height h. Let's consider. So the vertical height. So then the pressure at bottom here and the pressure at bottom here same, because if this liquid and this liquid are same, so the pressure is going to be same. The pressure, it's going to depend only on the height if the liquid is same. Okay, so based on that only we are going to do the questions here. So let's take this question. Four vessels, there are four vessels A, B, C, D, have different shapes, fine. So and hold different amount of water. So which of the following is correct? See here, I can directly say that. So I need the pressure at this point, at this point, at this point, at this point. So A, B, C, D points, A, B, C, D are E, F, G, H points, E, F, G, H points. So from here to here height is h, from here to here height is h, here also height h, and here also height h. So if the height is same, so the pressures at the bottom will be same. The liquid is same, right? In all of them, the liquid is same. P is equals to P naught plus rho GH, right? So here P naught is same. Here the atmospheric pressure, here the atmospheric pressure, here and here. And then rho is same liquid, and G is same, and H is same for all the vertical height. So the pressure also will be same for all the points. Done. Chal. So next, so let's analyze this question, guys. So there are three vessels A, B, C, D have different shapes, contain a water up to the same height. So water up to the same height. Here also water same, and here also height same, here also the height same. Fine. So they said contain a water in all of them. So the liquid is also same. So PA and PB, PC are the represents the pressure exerted by the water at the bottom of the vessels. So again the same thing, P is equals to P naught plus rho GH, right? For each of these containers, the atmospheric pressure is P naught, P naught, P naught. And then, so the density of this water is rho. So this water rho and this water also rho. G value is same and the height is also same. See here, so they are at the same level, same height. So H is also same. The pressures again same for all these three. Done? Chal. So now we have got the interesting question. See here. So the three vessels shown in the following have same base area. They have the same base area. Equal volumes of a liquid are poured. So equal volumes of the liquid are poured. So in the So then in the force on the base will be. So then what is the force on the base? On which base the force will be more? So this is, let's suppose this is vessel A, vessel B, vessel C. So the basic understanding. So equal volumes of water. Let's suppose I am taking some 5 liters of water. Equal volumes 5 liters of water I am pouring in this one. So obviously let's suppose, so the water will come up to this level, let's say, because as you are going up, so the shape is becoming wider. Yes. So then in this, so the water will come to up to this level, let's say. So this is height in the container A. The same 5 liters water you are pouring in this one again. So here let's suppose the height is going to be HB, right? And then so here obviously the height will be more. The same volume of water if you are pouring in this, so it will take more height. Shallow. So then it's going to be HC. So if you write the pressure formula, P is equals to P naught plus rho GH. So in all of these three vessels we have poured the water, same liquid. So water or some other liquid, oil or whatever it is. So then the P naught is same for this, and then rho is same for this, and G is same, and then H is not same. if you observe, the height in C, the height of the C vessel will be greater than that of the B and will be greater than that of the A, right? Sure, fine. So if the height at C is greater, so the pressure at C is more, then the pressure at B will be more and the pressure at A will be more. But they are not asking about the pressure. So what is the force on the base will be? Force on the base is maximum in which? So what is the force? Force is equals to, the force is equals to the pressure into area. They all have the same base area. They all have the same base area. Area of this one, area of this one, area of this one all same. Then, so the pressure of which one is more, so then the pressure, the force in that will be more. Here, the pressure of the C is more, so this A is same. Now, I can say the force is depending on the pressure only because area is same. So, I can say the force in C will be greater than force in B, then force in A. So, in which one the pressure will be, the force will be more? It is maximum in vessel C. It is maximum in vessel C. Clear, guys? Chalo, done. So we don't need another slide for this. Let's delete. So next we have, so one more question. So what's the question says? Equal mass of 3 liquids are kept in 3 identical cylindrical vessels. Identical cylindrical vessels. The densities are rho A, rho B, rho C. So given rho A is less than rho B is less than rho C. So the force on the base will be, see here, here they all have the equal mass and their volumes, they did not talk about the volumes, but their densities are different. So if their densities are different, obviously their volumes also will be different. Yes. So let me take first here. So this is the vessel A. So this is the vessel B. And then this one, the vessel C. So A, B, C. So there are 3 vessels. Fine. So equal mass of 3 liquids are kept in. So let's say the mass of liquid A is equals to mass of liquid B is equals to mass of liquid C. So then ABC, okay. So identical vessels ABC. So the densities are rho A, rho B, rho C. So whereas rho C is greater than, rho B is greater than rho A. Yes. So then their masses are equal. MA is equals to MB is equals to MC. Right. So now what about their volumes? So I can say that density is equals to mass by volume. Yes. Chalo. So if the mass is constant, if the volume is more, the density will be less. If the density is more, volume will be less. So I can say the C, volume of C will be less than that of, volume of B will be less than that of volume of A. Yes, volume of A will be more. So if volume of A is more, so then the density of A will be less. Yes or no? So now let's take some, let's assume some values because there are some different things are given. Volume is different, density is different, mass is same. So we cannot simply judge. So what we do is we just let's go for the values. So I am going to take let's say the density of A, let it be 1 gram per centimeter cube or 1 kg per meter cube. So density of B, let it be 2, density of C, let it be 3. So then, so the volume of A, so let the masses, they all have the same masses, right? So let mass of A is equals to mass of B is equals to mass of C. So mass of A is equals to mass of B is equals to mass of C is equals to, let it be some 6 kg I am taking. Okay. So then, so let me find, so in which one they all have the same base area. They all have the same base area. So in which one the volume is more, let's say in which one the volume is more. So in that the height will be more. Yes. So in that the pressure will be more. Yes. See here. So I can write here what is the area, let it be A1, let area A, and let's go for the volume of this. So the volume is equals to density upon mass. Yes or no? So the volume is equal to mass upon density, mass upon the density. So for the first one, volume is equals to, so mass 6 kg we considered, so density of A 1, so this is 6 liters, let's say. And then the second one, so its volume will become 6 by the mass of the second one. So what's, sorry, the density of the second one, so which is 2 we considered, so it's going to be 3. And the next one we have 6 by, so what is its density? 3 we considered. Yes, yeah. So this is going to be 2. So its volume is 6 liters, its volume is 3 liters, its volume is 2 liters. Yes, obviously their base area is going to be same. Their base area in all of them, it's going to be same. So now let's see the pressure in all these cases. So I can say that the pressure in the first one, the pressure in A is equals to P naught is same in all, right? So here height is equals to 6 we are getting, here height is equals to 3 we are getting, and here height is equals to 2 we are getting, right? So the height h, so which is nothing but, so I can write here, so rho GH, so pressure is equals to force into area. So pressure is equals to force into area, sorry, force upon area, and then force is equals to pressure into area, pressure into area. So what is the pressure? Is nothing but rho GH, rho GH. So here also you'll get 60, rho GH 1 into 6 into G is 10, 60. So for the second one also again rho GH, so 2 into 3 into 10, again 60. So for the third one also 2 into 10 into, so density 3, so again rho GH. So here rho GH is same, the pressure, here rho GH is same, and here the rho GH is same. So in all these cases the pressure is also same. So now they are asking about the force. Force is equals to pressure into area. They all have the same base area and the same pressure, so that it will be equal in all 3 vessels here also. It will be equal in all 3 vessels here also. Clear? Understood the concept? Chalo. So let's move further. So can you guys try this question as the homework? So I can say this is the easy question. The force acting on a window of area is given, so of a submarine at a depth 2000 meters in ocean. So the interior of which is maintained at the sea level, so atmosphere. Yes. So this question you can take it as a homework. Direct concept based question, formula based question. So P is equals to P naught plus rho GH. That's it. Okay. So now, so the PB minus PA, see here, B point is here, A point is here. So B is at a height of H2, A is at a height of H1. They are asking what is PB minus PA. So I can write, so the pressure at point B is equals to the atmospheric pressure, let's say P naught, so plus rho G H2, right? And then pressure in A, it's going to be, so P naught plus rho G H1. So they are asking PB minus PA, so which is nothing but, so P naught plus, so rho G H2 minus P naught minus rho G H1, right? So P naught gets cancelled, so I can write here rho G into H2 minus H1, rho G into H2 minus H1. This is a change in pressure. Clear? At 2 different points for the same liquid. Chal. So now the variation of fluid pressure along the same horizontal level. So always remember, so if the fluid is at rest, if for a liquid in equilibrium, the pressure is same at all points on the horizontal plane. If the fluid is at rest, or if the fluid is at equilibrium, static equilibrium, so then the pressure is going to be same at all the points. Okay. So suppose the pressure were not equal at different points of the liquid, then there would be a flow, as a fluid will have some net force. Yes or no? The fluid will have some acceleration, so there should be a flow, right? So hence in absence of flow, the pressure in the fluid must be same everywhere in the horizontal plane. So the pressure should be same if the fluid is at, pressure should be same at the same horizontal level when the fluid is at rest. So based on this, we are going to solve now the YouTube problems. I'll tell 1 or 2 questions, you have to solve the remaining questions, guys. See here, the YouTube in figure contains 2 different liquids in static equilibrium. So here is oil and here is water. So water in the right arm and oil in the unknown density rho x in the left. So if L is equals to 135 mm, D is equals to 15 mm, so what's the density of oil? So first thing is, see how to solve this kind of questions. First catch a point or identify a point where the density, the pressure is same. For the same liquid you consider, don't consider for the different, don't say that consider the point x here and point y here. So the pressure at x is equals to pressure at y, because here the liquid is different oil and here the liquid is different water. Okay, so what you do is consider a point. So I am considering a point x here and a point y here. Okay, so the pressure at x is equals to the pressure at y for the same liquid. Yes, so for the x1 I am writing the pressure P naught plus, so the rho of oil plus, rho of oil G into, so what is this height, total height, tell me here. So this height is L, this length is D, so I can write L plus D, so which is equals to, so the pressure at Y, so Y is, so the P naught, atmospheric pressure here P naught and here also P naught, plus, so the density of the water into G into, so what is the distance here, the L I can write. So P naught gets cancelled, G or else if you want you can write it in the next step. So rho naught G into L plus D is equals to rho W into G L. So G gets cancelled. So what is the rho of oil? We have to find it. So the density of the oil. So what is L plus D? L is 135, D is 15. So this is 150. So which is equals to, so rho of water, consider it as 10 to the power 3 into, so this L is 135. So if you want you can write it as 150 into 10 to the power minus 3, 135 into 10 to the power minus 3. So both 10 to the power minus 3 gets cancels each other, right? So then I need, so the rho naught, rho of the oil. So what I will get here, so 15 9s are 15 10s are, yes. So 9 into 10 to the power 3 by 10, yes. So the 9 into 10 to the power 2, so comes around 900, approximately nearly 900 value. So nearly 900, so we have got option 4. Clear guys? Understood the concept, this part, everyone? So rho naught into L plus D is equals to rho W into the length L. Yes, fine. So this is 15 10s are 15 9s are, fine. So this we sent it to this side, 9 into, so 10 to the power 2, fine, yes. Chalo. So let's go for the next question. We don't need another slide here. So let's go for the next question. So what's the question says here? In a YouTube experiment, a column AB of water is balanced by a CD of paraffin. AB of water, so this is water, is balanced by CD of paraffin, fine. So then the relative density of paraffin is, so let's consider a point here, consider a point X here, a point Y here. So the pressure at X is equals to the pressure at Y. The pressure at X is equals to the pressure at Y. Yes. So the pressure at X is, which is nothing but the atmospheric pressure plus this side the liquid is paraffin. So the density of the paraffin into the G into, so what is the height here? So the H1, so which is equals to right side Y, which is P naught, atmospheric pressure here P naught, atmospheric pressure here P naught, that's it. So plus rho of the water here into, so G, the height is H2 there, that's it. So P naught gets cancelled. So rho P G H1 is equals to rho W G H2. So I can write G gets cancelled. So the relative density of paraffin, which is nothing but density of paraffin by density of water. So I am bringing it to this side. So send this H1 to that side, it becomes H2 by H1. So this is nothing but the relative density of paraffin. Yes or no? So which is H2 by H1. Option 1 is the correct one, guys. Done? Clear? Chal. So let's move further. So we have one more question. So find X so that remains in equilibrium. The fluid remains in equilibrium. So here the diagram is not given. So leave this question. I'll take this in the next session. So here the diagram is not given. So can you guys take this question as a homework? So this one and the next question. See here. So take this as a homework too. Same concept, YouTube concept. So if you're not getting, I'll take it in the next class. So this question also you can take it as a homework. Homework 3. Done. Chalo. So that's it for the next first lecture of your mechanical properties of fluids. So just we understood how the pressure varies as we go inside the liquid. That's the first thing. And the pressure at the same horizontal level will be equal. So that's the second thing. Based on that, we have solved YouTube problems. So I gave some questions as a homework. Try them on your own. If you are not getting, I'll take them in the next session. So chalo guys, we'll meet in the next class. So till then, keep studying. All the very best. Bye.